I welcome you all for this video. Today we are going to discuss about network layer protocols. So first of all, we come to that network layer protocols. So in a network layer protocol, IP is the major protocol, and we'll see in this diagram where is the position of an IP, and parallelly those protocols in individual layers. Let's come to the network layer. Network layer is having so many protocol. The major protocol is an IP internet networking protocol, and additional supporting protocol IGMP, ICMP, ARP, RARP, and DSCP. The IP is located here, and the packets here going to call as a datagrams here. It is a best of delivery. Is a connection less oriented unreliable service in an AP. Whatever the packets or messages here going to call as an datagrams. So in a transport layer, three major protocols are there. One is the SATP stream control transmission protocol, transmission control protocol, user datagram protocol. Similarly, in an application layer, simple mail transfer protocol, file transfer protocol, FTP, terminal network, domain name system, simple network management protocol, and DSCP. DSCP actually plays a very much role in actually in a network layer, but it also in an application layer also. Next, come to that IPv4 Internet Protocol version 4 responsible for packetizing, forwarding, and delivery of the packets at the network layer of a source and destination. Parallelly, what is the process is happened at the source side, the reverse process is happened at the receiver side. This is what you are going to call as an encapsulation and decapsulation. Whatever the information get added at the source side, that information can be removed at the receiver side only after verification. The ICMP is an internet control message protocol. Else IPv4 to handle the errors, it will send in notifications back to the sender. What are the problems error occurred during a transmission. IGMP internet group management protocol helps IPv4 in multicasting. When multiple users are there, a common message broadcasting messages you are going to send by using the IGMP. ARP address resolution protocol, and address resolution protocols helps to find logical address. If you know the physical address, if you know the physical address, you can find the logical address. If you know the logical address, you can easily find the that physical address of the system. So as we know that first time to connect to the internet, we don't know the IP address of the system. You can obtain the IP address of the system manually. Then these protocols will beneficiary to get an IP address to the system which is connected for the first time. Now come to that, this is the datagram format, IP datagram format. So it is having header and payload. Header usually is having the addresses and the synchronous information. Payload is the user data. Packets used by the IP are called the datagrams. An IP protocol, that packets what you are going to use called as a datagram. Datagram is a variable length and also fixed size and also a variable length. Packet consisting of two parts. One is an header part, another one is a data part, user data. And IPv4, so that message format, data, you can just call as a datagram format, which is having so many field. Version is 4, header length, service type, total length is of 16 bits, identification, flag width 3 bits of flag, and fragmentation offset. Fragmentation offset contains the fragmentation information. Time to live is an 8 bit. Today for a 8 is a 256, is like actually the op count. Every time a node is visited, this is decremented by 1. Protocol representation is an 8 bit. Header checksum is calculated by 16 bits for the information. Source address is of a 32-bit IPv4. Destination address is of a 32-bit IPv4. Option plus 40 bytes padding, it is an optional one. We'll see version, actually the IPv4 version we use that. The flags, what is the D and M is indicating, so that information in that flags usually contains the information of flow control and duration informations. Actually, we know that the 4-bit version field defines the version of the IPv4 protocol, which obviously has the value 4. Header length 4-bit header length. The total length of the header is divided by 4, and the value is inserted in the field. The receiver need to multiply the value of the field by 4 to find the total length. And the service type, in the original design of the IP header, this field was referred to as service type or differentiated services. Total length defines header plus data. Identification flags and fragmentation offset. These fields are related to the fragmentation of the IP datagram, and the size of the datagram is larger than underlying network can carry. Compared to the what is the capacity of an underlying network, if it is more than that, we need to be fragmented. Fragmented information must be old in the frame format itself. That what is an flag fields is tells you that a fragmented or not that kind of information flags will hold. Time to live aliveness duration of a datagram. So what is the information it provided? Your packets is live. So after 256 counts, it will not yet reach the destination. It will vanish automatically because it create an unwanted traffic in the network. So the minimum hop counts must be provided. Minimum hop counts is tell you the time in which the packets or datagrams will definitely reach the destination. Otherwise, it's an unwanted traffic will be created by this, then it will be destroyed. A datagram can also carry a packet from other protocols that directly use the service of the IP, such as some routing protocols or some auxiliary protocols. It may use from ICMP protocol, IGMP protocol, TCP protocol, UDP protocol. That protocols type, that must be carry the information. If related to that ICMP is a 101 will be carry, for IGMP 02 will be carry, for TCP 06, UDP 17, OSPF open shortest path first, so the 89. This code will tell you that receiver the data is come from which protocol that. So header checksum is calculated by using in this mechanism. It shows the figure is having the different number of fields in a number format, right? By this for this you can calculate the checksum in this field. You are going to the checksum will be inserted. The checksum is inserted in the 16-bit checksum is inserted in this point. The checksum is calculated for this whole packet. Okay, our datagram. So how can we calculate it? We'll see in next slide. So in this slide, you can able to understand, you are going to insert the checksum for here. See, all the 16 data are extracted. Is actually totally it is from here to here is a 32 bit. Okay, half of that is a 16 bit. Take 16 bit data. The first row it is indicating 4500 is an first half of first row in the datagram. Second row is a 28 equivalent in an hexadecimal is an 1C. Next 49,153, it is C001 equivalent in an X. So then 00 is the next field is a 00. 4 and 7 equivalent you are going to return in an hexadecimal format. Then 0 as it is, checksum is as it is. The finally so 32 bit source of the 32 bit destination address divided by 2 like that. 10 12 equivalent you are written here. Then 14 and 5 12 6 and 7 and you are written. We calculated in this way. So whatever the sum come, that exceeded sum is going to call as an rapid sum. Okay, exceeded one, what it is comes, this is going to get added in this point. Okay, so now 344E plus 1, it comes to 344F. It's going to call as a wrapped sum. We added, one sum will come, that carry extended, the carry comes back and get added to the LSP. That after carry get added, that sum you are going to call as a wrapped sum. The checksum is nothing but complement of a wrapped sum. Okay, whatever the wrapped sum you get it by adding, then complemented it is a checksum. That is checksum, it is going to inserted here. The checksum is going to inserted. What is the locations is there, here in this field 16-bit checksum, it is going to calculated by this method replacing with data. Okay, option field can be used for a network testing and a debugging. Payload is a user data. Okay, these are the fields related to the IPV4 datagram format. So the fragmentation and reassembly, so it's a very important thing actually. If user is having a huge data, we can't handle in the network. So that's what, if anything happened and error occurred, whole data must be retransmitted. That is also one reason. Then we divided the user huge data into a smaller ones called as a fragments. So by using sequence number for that, so fragmented information must be all that how many fragments we made that. So we're giving an order that. So because the packets or datagrams arrive in a out of order in the receiver also, for ordering it will be very helpful data. Okay, so then next come to that how so the fragmentation we done that. So each fragment must hold an identification and flag information, and fragmentation offset addresses, offset informations must be provided. So 16-bit identification field used to represent the each fragment. It means that 2 to the power of 16 is equal to 65,536 fragments we can do by this mechanism. Datagram is uniquely identified using the identification field plus source IP address. Means each piece of information called as a datagram, that datagram is identified by source IP address and the identification field. Source IP address is tells that where it is come, which is the system, okay, in which device, which host is responsible for that, and the identification field tells you that which is the datagram, which piece of datagram it is that. When the